Question number 4 in 10.3. This is a triangle. We're still going to use the formula 1/2 apothem times number of sides times side length. So our apothem is given to us as 6. Remember, 12 is the radius of that circle that would be circumscribed. So 1/2, 6, it's a triangle, so there are 3 sides. Our only missing piece is to figure out the side length. So we'll use this mini triangle, figure out how long the red is, double it, and then plug it in. So looking at the way this is given, I see a shortcut on this question. I think I could use Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So c is our hypotenuse, so I'm going to use 12. So 12 squared equals 6 squared plus b squared. So if I solve that, I get 144 equals 36 plus b squared. Subtract my 36 to get 108, and then take the square root. So b would equal to the square root of 108. So that is the length of this side. And I actually have 2 of those, so I could just write this as 2 roots of 108. Then I'm working on simplifying that piece. Well, 1/2 and 2 cancel each other out. 6 times 3 is 18 roots of 108. And if you work that out, you get approximately 187.06. So if I approximate square root of 108, I get about 20.8. Number of sides was 3, apothem was 6. So here's an explanation of what we're actually doing. So I copied this triangle and I sectioned it into 3 bigger triangles. So this triangle 6, 12, whatever, is half of this big triangle. So just so you remember, this is that central angle and there's 3 triangles within that cross section. So if I find the area of one of those triangles, what I'm going to do is find the base and the height. So for one of these triangles, remember our formula for a triangle is 1/2 base times height. So the base we found was 2 roots of 108. And then the height is given at 6. So if I simplify that, 1/2 of 2 is gone, so I get 6 roots of 108. So I just calculated the area of this green triangle. But I also have the yellow and the pink triangles to account for. So there's a total of 3 of those green triangles. So this stands for the green, so I have to multiply that by 3. And that's going to give me 18 roots of 108. And from the previous page, that's what we had gotten. So when you're doing this 1/2 A and S, here's what you do. You figured out that a side length was 2 roots of 108. That apothem was the height of the triangle. So when you do 1/2 apothem times 2 roots of 108, that's the triangle. And the number of sides is calculating how many of those you need. And we needed 3 of those triangles. So really, this formula is a shortcut to finding one triangle and then multiplying it by how many there are. Let's try number 5. So looking at our formula, 1/2 A and S. Our apothem is given to us at 10 roots of 3. This looks like a hexagon, so it has 6 sides. The only thing we're missing is a side length. So what you could do is find the central angle, 360 divided by 6. So that means each angle is 60. Divide that by half, and this angle is 30. So then you could use your special right triangles. If this is 30, that means that this angle is 60. So opposite of 30 is 1, opposite of 60 is square root of 3, and opposite of 90 is double. The side lengths that we're given are 20 and 10 roots of 3. So to go back to the side with the 1, we can tell that that side is 10, which is going to make the whole side length 20. So if we multiply half of 10 times 6 times 20, we get 600 square roots of 3, which is approximately 1039.2. Try this last question by yourself, and then I'll show you the answer. Please pause the video. So our first step is to find that central angle. Otherwise, what you could do is look and say, oh, I could do Pythagorean's theorem with that. So my hypotenuse is 8, and then you get 4.6 for this b, and then it looks like I forgot to plug in and do double. So if this is 4.7 is what I'll round it to, then when I plug it in here, I have to do a whole side for 9.4. And that still works out to be this number. Otherwise, if you want to follow the same pattern as the others, our first step is to find that central angle. And remember that central angle is this entire one. So then we take half of that, and that's how our 72 became 36, because we're focused on this right triangle. So I needed to find this side here. So I called this opposite and hypotenuse, because I didn't want to deal with the decimal. So I did the sine of 36 equals our missing side over 8. So I do 8 times the sine of 36 on my calculator, which gives me about 4.7. So that's the length of half of a whole side of the pentagon. So I have to double that to get my 9.4. So our focus today is to find the area of any regular polygon. So what you're doing again is figuring out what is the area of one of those triangles off the central angle, and then multiplying it by how many we have. And in this case, we had 5. So the base of that triangle turned out to be 9.4. The height of the triangle was the apothem at 6.5, and then we multiplied that by half. So half 6.5 times 9.4 is the area of the green triangle, and if we section this off, we get 5 of those triangles within a pentagon. Thanks for watching my video.